Welcome back, Linux enthusiasts. This is the 17th episode of our Linux learning series. If you have missed any of our previous episodes, then you can check out the link above. In this video, we'll be talking about shell scripting in the Linux machine. If you're looking to upskill in Linux and get globally recognized certificates, you can check out our DevOps course. The link is given below in the description box. Alright, so now let's start the video. All right, so let's talk about shell scripting. So it's very important thing in the Linux systems. We have been executing commands so far, have been performing various operations. For example, creating directories, deleting directories, deploying web servers, deleting the services, restarting the services, checking the logs. Anything, whatever we have learned so far, whatever we have been going through in this Linux learning series, we have been executing everything on the Linux shell. So whatever the actions, whatever the command that we execute on a shell. So if we think like that, so that shell is basically I would say kind of application software itself, which has the capability to perform whatever the user sends any instructions or any commands to the kernel saying that I want to do ls. When you execute command ls, at that time kernel takes that execution command and then it performs actions whatever ls does and then returns back the data to you saying that okay, this is what the list of directories and files present in your present working directory, if you do just a normal ls. So all these operations that we have been performing, we have been doing on the shell. And shell, that application software, loads on the teletypewriter, that is what called tty. Okay, so if you look at in this machine, this execution of this command ls, what I am doing, so right now it is listing me the directories and the files which are present inside this pwd. So this is nothing but called a shell. If you want to see what is this shell I'm using currently, so you can execute command echo dollar and then shell. So we'll be talking about all these concepts of what is this dollar mean. I'll just give you a brief saying that currently it's saying that the value of shell which you are executing right now the commands on is /bin/bash. So this bash is nothing but a Bourne type of shell. So there are shells which have been deployed or which have been invented and worked upon. So with the time it got changed. So there are variety of shells are available. So like for example, if we talk about what are the type of shells present, so there are Bourne shell, then there is a she shell, then corn shell, and then GNU Bourne again shell. So these are the four type of shells which have been used mainly in the Unix systems. Now if we have seen the usage of shell is like any file execution that you do, any command execution that you perform on your Linux machine. The command line interface, whatever we see, is called shell. So it can be any shell. It can be bin sh, it can be bin ksh or csh or bin bash. These are the type of shells that we perform actions on. If there is any user who is watching this video have been expertise in zsh shell, so that is also advanced version of shell where you can get more options and a variety of stuff to perform on. So zsh is also again a very good shell, and you can do a lot of good jobs. For example, like GitHub, you can do direct integrations via zsh. You can change the shell prompt and whatever the things you do on the shell. So there are a variety of shells. It depends on use cases, whatever the user would want to use. So if we say that differences between how do you identify if it is a Bourne shell or a she shell. So Bourne shell, when I say Bourne, which is this BOURN. So Bourne shell is being identified who has this symbol called dollar. Okay, if you see any shell prompt which has a symbol dollar, that means it's a Bourne shell. So bash is also a Bourne shell. Okay, Bourne again shell, you can just say it's a Bourne shell also, Bourne shell only. But what about C shell? So if you see percentage, anywhere that shell is a C shell. It does not have that level of granularity in terms of features loaded, which Bourne shell has it, but C shell does not have it. So, but the representation is like, the references of a percentile sign. That's where you see for the C shell, but for the Bourne shell, it's a dollar. So that's a difference actually in these two shells to identify. Then some C type shells are present, like CSH is there. Then 10x is another shell called TCSH. So this is, I'm just talking in terms of you should aware about the type of shell. So TSH is 10x type of shell. It's again a C shell. So it basically defines, okay, this is a C type of a shell. Looks like percentile sign over there. So that is there. Now, if we talk about the little history of shell, so in 1970 mid, Stephen R. Bourne, he was working in AT&T Bell Lab, and then he designed that shell, kind of born again shell. So see, as we spoke in the very first chapter of our Linux learning series, right? That's where we spoke about everything which was invented, bought from Unix, and then took the adaptability about features and stuff. So that was, everything was getting invented or getting programmed in AT&T Bell Labs. So that's where the origination of all these things. Similarly for shell also, it was invented in AT&T Bell Labs, the initial version of it. After that, if you look at like any shell scripting that we are going to perform, so scripting is nothing but, I would say, it's a sequence of Linux commands that you execute one by one. Those commands either you can execute like on the command line, or you can create a file. In the file you can have multiple commands, and you want a file to be executed, which means all these three commands will be, let's say for example, will be executing. So small version of the use case I'm telling here. Let's say you're executing command ls. Okay, what I want is, and then you are executing pwd, but these are two commands that we are executing on our shell prompt. Now the use case is, you want these two commands to be executed in a single command. So there is one way actually, you can just separate it with the colon, semicolon, and then you can just execute like this. So this will be treated as a two commands. Okay, but these two commands will be coming up as a single command. So it will print the output of ls first. So this is the output of ls, and then it will print the output of pwd, which is a present working directory. Okay, so like this you can print. Okay, or let's say I want date also. So this will print all these three things. First, list down the contents present in my directory, then my pwd. After that, the date command output. So this is how you can separate multiple commands to perform. But what if you don't want like this? You want a command to be created your own command. Okay, so and you want these three things to happen, but in your own command, or in your own file. So that's how the need of scripting being defined. So scripting is nothing but like a language, if we talk about. So a language may have a complexity, but if in terms of simplicity, I would say it is nothing but a sequence of the Linux commands. So for example, so let's see, I have created some script here. So as you must have seen, so any script that you are going to create, for example, it should have prefix suffix .sh. So let's say there is a script called script1 script.sh. Okay, so this has a suffix .sh. This means it is telling the system that this is nothing but a script file. Okay, this is going to happen, execute on a shell. It's a script. Now if you open it, so it is telling you about that what this script is saying. So any Linux script, any shell script, if I would say, has something called a header. This header is called shebang header, shebang. So shebang header is what we call. So this header, if I would say a hash and then exclamation mark bin sh or bin bash, whatever, right? So this is called a shebang header. So this means this represents, this is currently in commented means it is not it's not applicable. When we execute this script, this line will be excluded, which means it is not doing any action, but it is just to represent, saying that whatever we are going to write just after it is a shell script. So we are telling the system. So that's the importance of shebang header. That's how you define the shebang header, uh, and after that, you must have seen there are 3 lines which are currently commented. That means it is not going to execute. But if we focus here, so there are commands that basically, what this script is doing is echo command. Echo command basically, prints whatever you write after it. So let's say if I just copy this here and go to another terminal and then paste it and execute, it will just print me what is your name. Okay, so this is the echo command. So we are using this command. After that, we are using another command, that is a read command. So this read command takes the output from the input that you provide on the shell, okay, and then it stores into a variables. So here it is storing into a variable called person, okay, and after that also we are printing, we are again printing via echo command, and then we are saying hello and then $person. So if you basically want to print the value of any variable, you use dollar signs. Okay, so this is a simple trick. If you want to print the value of any variable, you can use dollar sign. So here, whatever the action, whatever the input that we are going to provide on the shell, it will be stored under person variable. We'll be talking variables in upcoming chapters. What are the variables and how do you provide the output of the variable, how do you store that. But I'm just showing up here. You can just don't get confused, you can just get an idea about how does a shell scripting being written. So if you look at like this way, it is nothing but a command sequence of commands. So there are 3 commands. First command is echo command, then read command, and then after that again echo command. Okay, this read command also, let's say if I say read person, okay, so it is asking you for the prompt. It is opened a prompt. Now it is asking you to input something, let's say if I put my name, okay, and then I press enter. So as soon as I press enter, this value Himanshu is being stored under variable called person. Okay, if you want to print out the value of this variable, you can just do echo dollar and then person, okay, and then it will print me the value. So this has become a usage of command read command. Okay, so if you look at this script, it will first print me what is your name, then it will look for any input that you provide your name, and then it will say hello, whatever the name you are going to provide. So now let's save this. Okay, one more thing is to make any file as a script, if you look at the permission of this file, so you notice we have an execution permission X. So if you remember, in the permission chapter we spoke about, X means executable. You are making any file as executable. So when any file becomes executable, that colors also gets changed. It's green in color. So this is advantage of Bourne shell that we are using bash. If we would have used C shell, you would have seen this in the normal white in color. So it will not discriminate in terms of define okay which color to what, in terms of directories to blue, files to white, executables to green. So it does not do that. But Born Again shell has this feature which shows up in a very good way, where you can just identify by the color itself what kind of a file this is. So by looking at this, and we have verified, okay, this has executable permission, anybody can execute this script, you are able to execute. What if I remove this executable? So chmod -x, if I remove this executable from all these 3, so you have to remove let's say others, or you have to remove one by one. After that you will see color change there. Okay, so now you see earlier the color was in green because it had executable permission there, but now there is no executable permission. That is the reason you are not seeing green in color. So that is how the shell is basically giving you, just by looking at the color, giving you a feature to identify which kind of a file it is. So now in order to, if I try to execute this shell, it will not execute because it does not have executable permission. Let's try it. Now we have stored commands, and then we are going to execute a script. So there are multiple ways to execute. One way is using, let's say, bash, that saying that I'm using bash command to execute a script. Okay, so now it says what is your name. If I say Himanshu, and then it prints me hello Himanshu. There is one way. But if I try this way, it will say permission denied. If I try sudo also, it will say command not found. Why is it saying command not found? Because this way you are trying to execute this one script.sh file as a executable, as a command, you know. So this is not working currently because it does not have execute permissions. But as soon as you provide executable permission, it will work. See, so that is how you can execute a script. So there are multiple ways we spoke. You can use like sh also. So this means that you are using sh shell, not a bash shell. Rather than you are using sh and you're executing the same way, you know, you execute via bash. So yeah, that is how you can execute a shell, and that is how you can you know, write contents inside the shell. So you can see it here. What if, let's say, I try to create another script, let's say basic script, okay, and then say shebang header, okay, now say pwd and ls. Okay, you can automatically see as soon as I typed the command, the color changed here. But if I say Himanshu, the color does not change because Himanshu is not an existing command on this system, but pwd and ls is the command. So what I was trying to say, just to make you understand why and how shell scripting is so easy, basically it is a language, but this language is used for the commands that you're going to execute on the Linux systems, but to make it a single executable file rather than executing one by one each commands. So now let's save this file and say bash basic script.sh. So see, it has printed me the output of the pwd and then the output of ls command. If you look at the structure of this script, first it has a pwd and then it has ls. So that's why it printed me the pwd command output first, and then after that ls command output. So it is nothing but a sequence of commands that you are going to execute in the Linux systems. So that is the advantage of being using shell scriptings, where you don't have to execute one by one each command. So that's how, very basic, I'm just trying to tell you that this is how you can write the shell scriptings. You know, that's how you can write the scriptings. After that you can make modifications. We'll be talking about slowly what are the loops and variables and whatnot stuff are present in the shell scriptings. Okay, so that is, we saw it. What happens, let's say for example, if there is you know, let's say if I uncomment it and then save this, Himanshu is not a valid command. Now let's see. Okay, so it will again print, it will execute the starting two commands for you because those commands are legitimate. It's not like, you know, it will break at the first step itself saying that, oh, this command is not found. No. So you can, if you look at the way the shell scripting executes it, it reads line by line. Okay, so the line, the first executable line was pwd, so it executed the output of pwd, after that ls, and then once it reaches to the output Himanshu, it says Himanshu is not a valid command on this system at this moment. That's why you are unable to, you get this error, Himanshu not found. The same error you will get when you execute this command. So it is a sequential execution of the commands that you're going to add on in your shell scripting. So that is how it works. Okay. Now, so it's like, that's why it is so easy to get it. So if we're talking about the prompt, this dollar sign, which is useful for kind of an indication as well, to provide the value of any variable, as well as it can provide you the idea about this is a bash shell, this is a born again shell, or born shell. If you say echo dollar date, so this is how it can print like this also. So you can use this tilted sign, which is nothing but uh, below the escape key in the MacBook. So tilted, so this takes as a command itself, and then it prints the command for you. After that, this dollar is also came in the echo, so it's just printing that value to you. So that's how you can do. Then for example, date command you can execute. Okay, yeah. So dollar is not a command here, that's why you're not getting anything, but date is a command here. And then it is, so this means something else actually. We'll be talking what are the spatial features of the shell scriptings. But date command is like any command that you can execute here, that's what it is happening on the shell actually. If you want to change the session on this shell, okay, so you can use command bash. So bash will, it looks like same terminal, but it is not same. The reason being, how can you identify is, let's say check history. So in this, is this prompt, you don't find any, we executed some other commands, and exit and then do history, you will not find this echo, this is and all. See, so history itself is different, which means you have created a new session in the shell. Either you could have logged into the same user to a different window, or in the same window you could have done that. But instead of doing that, if you want to change the session, you can just execute bash and it will change session for you. It will create a new shell. Okay, you can exit and then come back, or sh also can take you, but it will not give you that good PS1. We'll be talking about what PS1 is again. But yeah, this is how you can do sh. All right. Now, when we, if you remember earlier also we discussed about this prompt when we were copying the files while creating the users, that skeleton is being copied over from etc scale to the user's home locations. Similarly, that those files also has PS value. This is the prompt. How does a prompt should look like? Okay. So I'll just recall it. This was the file in the home directory, bash rc. If you search ps1, you will get the prompt. Okay, so this is the ps1 which is currently active. So this is the primary prompt. Okay, there is some other prompt called secondary prompt, ps2. We'll be talking about that as well in a bit. So ps1 is this value. This is a default value. Okay, if you don't want to make any changes in the permanent file, which is .bashrc, but rather you just want to do here only for a short time, so you can use command ps1. So you can give like this ps1 and let's say any prompt. Okay, so once I give this, it will change it for me, but that is not persistent. When I say that, what does it mean? If I execute bash, it will create another file session for me, and then at that time it will read that file bash rc again. And in the bash rc we have proper format of ps1, that's why you will see the proper one. But now this is how you can change. You can change anything. You can add variety of colors, you can add images or emojis or whatever, right? You can Google it up the way how to add colors there, and I'm just giving you an idea about how do you change that actually. For example, let's say you change it, let's say this way. So there are more options, /use for user, and then host /host, okay, and then let's say /working directories, and then $, $. Okay, see the difference now. You can see this is a user, This is what slash u presents. And then slash h is nothing but a host name of this machine. Then there is a space after that. So you notice there is a space here. Then working directory, this is your pwd. After that, this prompt ends with this sign, big bracket, and then dollar, okay, which represents the prompt again. So you can change anything. Let's say, for example, instead of, so there are many options. For example, you can just say instead of working directory, or give me time. So this will give you the current time. So the current time, let's say the current time is what, 1:55. So it is taking 24 hours clock, and then it's saying, okay, this is your current time, automatically updated. So this way you don't have to again go to the clock and then see the time. Okay, by looking at the prompt itself, you can just see what is the current seconds. Also, you can see that seconds are also changing here, you know. So this is a kind of a good advantage of changing the values of ps1. And if you want to make this permanent, you can make in the bash rc and then added that entry of ps1. It will, once you replace it with this entry, it will go, it will take it up, and then you just have to source that file. We will see that, you know, how to make it permanent, but let's review some other options as well. Then hyphen t, then there is a hyphen d. You can say date, okay, Monday January 20th. So this will print like this. What if I just don't want, I just want user and then day. So then remove this start, and I want to say something like this. Anything you can just add, whatever you would, you feel, you know, anything you just. So this is the advantage of being using Linux. You can change anything, you know, in Linux. It can help you perform any actions. So you can have now, you know, the date and then time. So you can change it like this. Or let's say, for example, shell also it will print. Or let's remove this. Give it then slash s. It will give you the shell. It is currently using bash shell. What if you want to see w? So this w, capital W, just give you the present directory name, which is shell underscore scripting. But if you remember small w gives you the relative path, basically, you know, that relatively where are you currently. So relative path is different than absolute path, if you remember. So relative path can start with the, you know, like dot, double dot, or this tilde sign as well, like just to represent this is the home directory of my user. And then, you know, you're just changing. So for example, like currently pwd is this. If I say it's cd and then tilde, which means I'm going to the home directory of the user star agile. Okay, so, and if I want to go back into the shell scripting, so I can just say cd hyphen, it will take me to the previous location where I was before. So that is the change in the prompt, w and small w. Okay, I'll remove this. I have this thing only. Now there is another example, user, yes, we have seen here. Then host also, let's say this thing slash this thing. So this will basically to give you the current command. So this increases actually, like for example, you know, ls. Okay, see now it is changing the numbers. So it is saying that in the history, what is this number of that command, 601. This is now whatever you're going to execute will be 602. So this is how it is actually executing and telling you to do that. So that is another good stuff you want to see. But these are like the use cases depending on if there is a requirement to do the same. Otherwise, it's like just to play around, you should be aware about there are a lot of options, and then you can just read the manual, and then, you know, it will give you whatever you would want to make a change. So yeah, so it's like, you know, you can just play around with it. So we will see some other options as well. Let's say $, it is just printing the uid for you. If you're logged in as root, password. Okay. Let's say now it is taking this way. Yeah, so see, for a root, we spoke that it shows hash, but for a normal user, it shows $sign. So that is a change in the shell prompt. You can just identify by reviewing. Oh, hash is also coming up here, and then here dollar is coming. So that is how it is. It defines or it identifies. So this is a normal user. This is not root. So now what we will do is we'll make it again changed to what we were doing. Okay, now say host name, remove this time, and then say directory. Yeah, now this looks good, understandable. So you can have n number of options that you would want to apply here. You can just keep on adding this, and then it will take effect. But this is all local. When you open a new session or you log in, let's say if I log in here with for user star agile, you will see a different prompt. Reason being, I must have set up something in the bash rc file which list out this thing rather than having a host name, just something like IP address or something. So you can make change whatever you would want to based on the file has it. But now let's review the permanent changes that you can do and where you can do. So there's a file called bash rc. Now this bash rc file, if you make any entry for ps1, if you look at ps1, you will see this is the entry currently for star agile user. It's local and it's different for every user. So if you just want IP address, hostname -i is the command. So currently you're seeing here username @ and this is IP address. So this will give you the IP address, but it also gives you the MAC address also and IPv4 and whatnot, right? So this is the tweak I did here using awk command just to filter the first value, print the first value. So that is how it is actually printing and adding up in my PS1. So instead of that, you can just make a change like, say PS1. I just want user @ and host name. That's it. Okay. And if I comment this line here, so now this line will be treated, and I've saved this file. But currently this file is not again sourced. Sourced means this file is not being read until you reboot the machine or you relog into the same user star agile or you create a new session. But I don't want to do any of this. But then how again I can read this file and make it as a reloadable? You can just think like you make some configuration changes for Apache and then you can reload the config Apache daemon, right? Similarly for bash rc and stuff, like any source files, you can just execute command source. That means you're sourcing it. You're asking system to read this file again. As soon as you do this, you will see the ps1 value changed. And if you print echo $ps1, so you will see the difference what you are actually using. You are just saying user and then host name. So that is what the current value is being taken for this. Now let's go back to bash rc and make this change. So this is the permanent change that we have done. If you log in, let's say another terminal, and use the zoom it up. Okay, and you log into star agile, it will again read this same bash rc for star agile, and it will have the same prompt until you, because you make this permanent. But now I don't want it to make permanent. I want it to say dd and okay, and let them be permanent. Source and then bash rc, and that will make it back. So that's how you can just play around with bash rc file. You can just source the file and then you can change the prompt, whatever. You can have any sort of color. So currently it's in green color, you can have in different colors and stuff. You can just change that. You can just google it up, how to make it more imported, like emojis and stuff. You can just add those things as well. So people do that. It's like just to see the things fancy, but yeah, you should be aware this is nothing but a PS1 option for Linux. You can just change in the shell settings. Okay, now there is one more thing called secondary prompt. So this secondary prompts basically, what it is if I say PS2, so this is secondary prompt, $PS2. So currently my secondary prompt is secondary prompt, and then this arrow sign. What does it mean? I'll tell you. How do you see this? For example, let's say echo command, you are using double quote. You have opened a double quote and say this is your learning series Star Agile, okay, for example, and then you forget to end the quotation, okay, and then you press enter. So once you do that, you will be gone to the secondary prompt. Okay, this was a primary prompt and this is a secondary prompt. So now here, until you type something else and then enter, then something else, then enter, so it is not taking the entire output. So it will take the entire output. It is expecting you to end with the double quote also. So as soon as you say double quote and then press enter, so it has taken all these content that you have provided till here, then here, and this. So this has provided you all these things. So this is nothing but called a PS2. This is a secondary prompt. You can change that as well. Like for example, say @ something, some fancy stuff. Now let's say echo. See, now it will change the secondary prompt for you, but this is again at the local level. It is not has done in the permanent. So if you want to make it permanent, you can again go to bash rc and you can append an entry called PS2. Currently it is secondary prompt. Once you make it change, let's say I want to comment this and then let's say I want to make it like something like that, okay, and I will source it. Once you source it, and then let's say echo, and then it will take the secondary prompt as a persistent because it has already sourced it. So that's how you can play around with it. And once you close it, so any prompt, it's based on user choice. It's nothing to do with the admin or nothing to worry about that something will break. No, nothing will break. It's just that how a user interactions of a shell that you are basically doing, you can just manipulate things. So that is what the customizable functionality of Linux, it leverages. It provides the facility to the user, saying that you can change anything, whatever you would want to. So similarly for shell also you can change the prompt. So for now I will just remove this and make this applicable and source it again. Okay, see, secondary prompt, that's it. So that's how you can just play around with the shell, and you can various options you can use, and then you can, based on that, you can change the settings that you would want to change. So yeah, that's about the introduction of shell scripting in the Linux. If you want to learn Linux and get certified from IBM, click on this link given below in the description. That's a wrap for this chapter. I'll meet you in the next episode of this Linux series.